lesson 2.4, algebraic reasoning. So we're going to talk about some different properties of equality that we can use to solve algebra problems. So the addition property, if A is equal to B, then I can add the same thing to both sides and it will remain the same. So I could do A plus C equals B plus C. I've added the same thing to both sides. The subtraction property, if I had two things that are equal, I could take away something from both sides, and that would be subtraction. Multiplication, if I knew that A equaled B, then I can multiply both sides by, let's say, 5. So I could have 5A equals 5B. The division property, if I knew that 2A equaled 2B, if I divided both sides by 2, then A would equal B. So notice for all four of these, they all had to do with doing something to both sides of an equation. Distributive property is when we actually just distribute. You have a set of parentheses with something added or subtracted, something to be multiplied outside, and we are distributing to the two things. So that would become A times B plus A times C. And then simplify. So we're going to use simplify when we're kind of reducing one side of an equation. So that would be like we're combining like terms or reducing a fraction. So if you knew that 2x plus x was in one line, then you can turn that into 3x, right? We can combine our like terms. So we're going to use the different properties of equality to solve an equation, and we're going to do it in the format of what we call a two-column proof. So the left side, we're going to list our statements, which when we're doing algebra is just the steps of the proof. And on the right side are the reasons why we were writing the statements. So those reasons, the things that we can use as reasons, would be those properties that we just learned. It could be definitions of any word that we know. No, I seem to have frozen here. Let's just wait for it to catch up. Okay, that froze for a second. Sorry about that. Definitions, postulates, and theorems. So let's do a problem. We're going to do this algebra problem in the two-column format. So instead of showing, like normally I would show +5 under this and +5 under this to solve. Instead of showing +5 and +5, I'm going to write what I get after I've added the 5. I'm going to write that I used the addition property, because that's what I've done. I've added a 5 to both sides of my equation. When I added 5 over here, it made this go away. When I added 5 over here, it turned it into 18. And then my next step, if I wanted to divide both sides by 2, I would get x equals 9 after I divided, and I'm going to say that I used the division property. Let's do another one together. So here I have x's on both sides, so I usually want to get all the x's together. I'm going to start by adding 4x to both sides. And if I add 4x to this side, I get 7x. And if I add 4x to this side, I just get 23. So that was the addition property. And now I want to move this 2 over. So I'm going to take away, I'm going to subtract 2 from both sides. Subtracting 2 from this side goes away. Subtracting 2 from 23, I get 21. And that was the writing the wrong thing, subtraction property. I'm going to ask that you abbreviate a subtraction. I'm okay with abbreviations, but abbreviate subtraction to SUBT instead of just SUB, only because we're going to learn another word that can also abbreviate to SUB, so we can't put either of them as that combination. All right, and then our last step here, we would want to divide by 7 using the division property. Here's a problem for you to try. You can pause and give it a shot, and the answers are posted online. All right, sorry if that was another weird transition. My computer keeps freezing up. So let's look at another example. So this one's going to involve the distributive property. So I'm going to start by just rewriting the negative 10b, and now I'm going to distribute this positive 6. So that's plus 12, and then minus 6b equals 4, and I'm going to say that I used distributive property. And now I have to combine some like terms. I have a negative 10b and a negative 6b, but they're on the same side of the equal sign. So combining them, we get negative 16b. And we're going to call anytime we combine like terms just simplify. If you want to write combine like terms, that's fine, but we'll just call it simplify. And now I'm going to subtract 12 from both sides using the subtraction property. And my last step, now be careful because we're going to want to try to divide by 8 because that's the smaller number, but really the number with the b here is the negative 16. So I'm dividing negative 8 by negative 16, and I get 1/2, and that was the division property. So here's another one for you to try. If you'd like to pause, you can check your answer online. So we have a few more properties. We have the reflexive property, and that's for any real number A would equal A. So reflexive, like your reflection. If you look in the mirror, you see yourself staring back at you. So you are equal to yourself, reflexive property. The symmetric property, if you imagine a butterfly has symmetry, right? If we were to draw a butterfly, what we draw on one side, we would match on the other. So if A was equal to B, then symmetrically, B would be equal to A. It's the reverse of it. The transitive property. So transitive property, I think of it as linking two things together by what they had in common. So if A is equal to B and B is equal to C, I can link together the two B's, and now I can get A is equal to C. Substitution is when you're replacing something with something equivalent. So it's not quite like transitive. There's a little bit different. So if you had, let's write replaced. If you had A plus C was equal to D, and you knew that A and B were the same thing, I could rewrite this equation as B plus C equals D. The main difference between transitive and substitution, when I'm looking at a statement like this, and I have B plus C equals D, I've never seen B plus C in any of my steps before. It's a brand new thing formed by replacing something. When I'm using transitive, I've seen A on its own before, I've seen C on its own before, but they had the same thing in common. So transitive is linking, substitution is replacing. So let's look at these properties and just state which one we see happening. So if the measure of angle A is equal to the measure of angle B, and the measure of angle B equals equal to 42, then the measure of angle A is equal to 42. So I see two different equations. Oh, sort of phrasing. Two different equations equal to the measure of angle B, so I can link together the measure of angle A and the 42. So this would be transitive. If the measure of angle 6 is equal to the measure of angle 7, then the measure of angle 7 is equal to the measure of angle 6. So we reversed it. We were looking at some symmetry there. So this is the symmetric property. And our third one, x is equal to x, so we're looking back at ourselves like it's our reflection. That's the reflexive property. So this is the last check-in. You could pause if you'd like to try it. Answers are posted online. That is the end of section 2.4.